Okay, number one, integral of dx over x to the 2/3 times 1 plus x to the 1/3. Too many terms in the denominator. We know we can't expand our way through. This doesn't look like a synthetic division problem. This is a U substitution problem. So I like to pull the dx out in front, so it just, or outside the fraction, so it just looks more consistent with other problems. We see a set of parentheses, so it looks like that could be a target for our U value. Do some cleanup before I cross multiply. Here I'm dividing by -1, but dividing by -1 is the same thing as multiplying by -1, so I just brought the negative up to the top. Make my substitution. I should have a nice matching pair with that x to the 2/3. That should go away nicely for us. Don't forget about that -3. Push that out in front, and then we should be able to find a rule for us to use. It's got a nice match with my natural log rule. Remember, it's 1 over u to the first power. That's the only time we're using natural log. If it's any other power with that u variable, we got to go through power rule. Got to bring it up to the power. Oh, I messed up here. I don't know why I put that negative there. It should be a positive 1/3. There's no negative here. Sorry about that. The negative exponent shows up after the derivative, not before. So it's just 1/3 x to the -2/3. Number 2 is a long division problem, which we're not going to do. So if we can change that denominator to just be x plus 2. So number 2 fits nicely with what we expect with synthetic division, which is a denominator that's a linear, two terms, a linear term like x plus 1, x minus 3, x plus 5. And then your numerator has no radicals. It's just usually degrees is higher, but it can also work if the degree is the same. But there's obviously higher here. But careful, there may be some degrees that got skipped over, so we need to have a placeholder for them. You're always taking the opposite sign of the number that you see inside your factor there. Okay, 1 for my x to the 4th, 0 for my x cubed, 0 for my x squared, 1 for my x, and -4 for my constant. Always bring the first number down below the box. Whatever number you see outside, you're going to end up multiplying. Whatever you see inside the box, you're going to add. Okay, check my work. Is that what you guys got? You're dividing by x plus 2, so you're starting off with x to the fourth, but now you're going to begin at x cubed. So make sure that your starting degree of your the result of your synthetic division should be one lower than your numerator that you started with. So this is x cubed, this is x squared, this is x, this is constant, and then finally my remainder. Okay. I want us to understand that when you go through synthetic division, you're splitting up this fraction into easier parts. We haven't found the answer yet. We've just made it easier for our calculus procedure, but we still haven't found the antiderivative. So we're still at the original level. But it should be easier now because a bunch of these terms are just going to be power rule. And the last one is where the u substitution and natural log will come in. And this is u value being the x plus 2. This ends up being natural log. The 10 is the coefficient. Number 3. Number 3, we don't have a rule that looks like that, right? There's no rule that's secant tangent over secant x minus 1, which tells us it's too complicated for one rule to handle. We got to go through u substitution. So our u value, if you're having to choose between numerator and denominator, and if you're considering u substitution, it's typically the denominator that will be the better fit. So let's let the denominator be our u value. See where that leads us. So secant's derivative is secant tangent. -1 goes away, cross multiply. Make your substitution. One over u du, natural log. Okay, number 4. Notice that there's only one term in the denominator. This we can actually split up because both the numerator and denominator are within the same family of functions. We can just split up into 3 smaller problems here, just like if it was like 2x squared plus x plus 1 divided by x squared. So because these because there's only one term below and both of these above and below are same family, we know that we're able to make progress if we split up and reduce. If we want to combine, we can subtract exponents. 2x minus x is just x. So have e to the x. That's one problem that I can do. The e to the x is canceled out, so the only thing left is just 2. And the third one is just 1 over e to the x. But we know that 1 over e to the x is not a rule that we can handle. If we want to do e to the x, it's got to be in the numerator, so we got to make it e to the negative x dx. You don't need to do all 3 separate integrals. I just want to show that I just want to highlight and emphasize that these are 3 separate problems, right? They're all going to be able to make, you can make a separate rule and we don't have to consider what's happening around it. Each of them are its own independent rule. So e to the x is e to the x. That's nice. 2 is 2x. But this, we have to do a little bit of use substitution here because this negative x is standing out. So there's going to be a little bit of leftover here with our use substitution here. So basically, that negative x will produce a -1. And so my integral of e to the negative x is just e to the negative x, but then there's -1 left over there. So we have e to the x. That's not going to change. 2 becomes 2x. And e to the u is e to the u, but then there's a -1 left over. So minus e to the negative x plus c. So we had to go through a little bit of use substitution here because this is a little bit more than just an x. The reason that we can skip use substitution here, I mean, we could, but we knew that x's derivative is just 1, so we know that there is not going to be any leftover to keep track of. Number 5, ignore the bounds. E to the 3 over x all over x squared dx. This is too complicated for one rule to handle, so we're looking at use substitution. Okay. Let the u value be the entire exponent and see where that takes you for number 5. My u value is 3 over x, which I want to get it ready for power rule to find the derivative. So I bring that x up, 3x to negative 1. Power rule, I get negative 3x to the negative 2. Clean that up. Pull the x squared back down. Cross multiply. Divide by negative 3. dx equals x squared du over negative 3. It's a good sign, seeing that the x squared should pair up nicely with this x squared that we're hoping to match and cancel each other out. E to the u is nice because it's just the integral is the function itself. So after we find our antiderivative, we can drop our notation. But we know now we can think about bounds here, but not yet because the bounds are in terms of x. Let's bring back our x variable, and then we can do our half bracket with our bounds. Upper bound first. All right, number 6. Use substitution with the denominator here. All right, so this, we run into an issue here. Use substitution, but the x is not going away on its own. We have to play around with our assigned expression and solve for x and make our change of variable use substitution there. Divide by 3, or multiply by 1/3. Now I'm going to take that and put this into here. If I pull the coefficients out, 2 times 1/3 times negative 1/3 is negative 2/9. So it ends up being negative 2/9 in front. And then I have 2 minus u over u du. There's only one variable below. I can split this up. Natural log and u sub and power rule. Oh, sorry. I think 2/3. I don't know why I put. I would have the 2/3 there. My bad. This is a 1. Yeah. Okay, replace the u back in terms of x. And then 2/9. This is a little messy. Okay, your homework is page 11 and 12. We did a good chunk of that. Just have to finish these 2 pages. The key is attached, so you can check your answer with the key. Tomorrow we'll start 6.3 differential equations, which is not going to be on the quiz, but we can still spend some time reviewing tomorrow. Your quiz is on Thursday. Okay, so tomorrow morning I'll have a help session 7:30. Thursday morning help session as well. Okay, but it's basically just going to be, these types of problems. Okay. All right, come to your phones. I grabbed these. I grabbed it on the calculator and I looked at my x intercepts.